All right, so hello everyone. Today we're going to talk about the normal distribution and we're going to explain it simply so that we'll be able to understand its properties. So, this is actually a prelude for us to understand the central limit theorem. So, without further ado, let's now go ahead, right? All right, so we actually see normal distribution usually being shown in statistics class. So basically, what we see when we have a normal distribution is that it looks like this. So there's a, say for example, there's a line there, and then we see that we have a curve. Let's just try to make it as normal as we can. And then, so basically, the mean is found here at the center of our normal distribution, and then this is actually called the mean. So the mean, or we also call it usually the x, right? So the mean, when we look at the normal distribution, um, this is basically a probability distribution, right? So why is it a probability distribution? Basically, what you see here in the y-axis is that this is the frequency. So let me just write it down. We call this one the frequency, and all the rest here are values, right? So let's say for example these are weights of all women in the world. So basically most of the women in the world, if you count how many of them weighs around 65 kilograms, right? So basically more of the women in the world basically weighs around that value. So as you can see, this has higher values because it has higher frequency here, right? So in this portion, we see that there are many more people who are weighing around 65 kilograms. But if you go beyond 65 kilograms, then you will notice that there is um, a lowering down of frequency. Let's say, for example, it's rare to find a woman which is around 100 kilograms here in this part, and you see that the curve has lower frequency in this part because remember this is the y-axis here. It's the frequency. So basically, less and less women weighs around 100 kilograms. But if you also go to the other side, let's say for example, there's a woman weighing around 10 kilograms, you will notice that there are a few of them actually who weighs 10 kilograms. But if you move around 50 kilograms here in this part, right, so whatever it is, you see an increasing number of women having that weight. But if you go to this side here, right, so you see that majority, right, of the women actually weighs around 65 kilograms. And that is the reason why if we use the mean, it is a representation of the majority of people, right? So in terms of weight, majority of people more or less weigh 65 kilograms, right? So that is how we understand a normal distribution. It's a frequency distribution, and the thing is, the closer you are to the mean, higher the probability that you would belong to that level. All right. So one of the most important points that we need to consider when we're having a normal distribution is that the mean and the median, usually if there are no skewness, or if it's a really pure normal curve, the mean, let me just write it here, the mean is usually equal to the median and even the mode. So basically, if it's a normal curve, so there are no skewness, etc., there are no outliers. Basically, the mean, the median, and the mode are equal. All right. So another very important point also is to consider the probability of having specific values. So if we try to place another normal curve here, make it as straight as much possible, then if we have a normal curve, And then if we divide the normal curve into two, is that a perfect normal curve yet? But basically, the idea here is that 50% of the people would belong to the other side. Okay, so let me just color this one. All right, yellow. And basically, on the other side, you will see that another. All right, so one of the major points that we need to take note that this is the reason why we can build what you call confidence intervals. So this confidence intervals is actually based from the property of what you call the normal distribution, and it's because of the 68, 95% and 99.7%, we can create confidence intervals around our mean, our population mean, so that we'll be able to estimate the probability of it belonging to the true mean of the population that we are studying. So in the next video, we'll talk about how do we estimate these confidence intervals. Right, so I'll see you in the next video.